So welcome to the 39th edition of our Physics Matters series. So my name is Christine Dove. I work at the European Space Source in Sweden, and I'm sharing the Forum of International Physics, the FIP. So this popular science series is organized by the FIP, the American Physical Society, to advance the knowledge of science across borders. So Physics Matters series foster cooperation for and by developing community around the world. And it was initiated by the idea of the Sesame Light Source, so in Jordan. So this is an open access and live scientific expedition where everyone can contribute and meet online our exclusive invitee. So we can all visit as well the webpage where the 38 previous recordings are stored. So our renowned speakers have presented there more tools for discovery and exchange with world scientist experts. So in particular, so last December, 14, we had the pleasure to meet Professor George Ellis, who described life from South Africa, the interaction of physics, environmental and development issue, hence taking complexity seriously. So that event was taking place simultaneously with the closing of the International Year of Basic Science and Sustainable Development, directed by the UNESCO, the IUPAP, and it was at CERN. So both those events are able to trigger actually today's forum. So we have gathered, with Professor George Ellis, live this time from Germany, a panel of experts who produce another sustainable episode, to build up a constructive way forward. So based on today's forum, we want also to raise different action items. And what we would like is to follow up later this year, sometime in June, the 27th of June, and to organize another event. We will see what the follow-up of those action items have been, to be concrete. And we will have at that time, more follow-up also and looking at the event that we will describe a bit further today. So the way it will be organized today, we will first listen to a presentation by Barbora Bruant Gulejova, who will then present 15 minutes wrapping the provocating question that will be useful for understanding how this sustainable development could be looked at. And with our panel, but as well with you. So we want to engage you with further questions. So our panel today, with Professor George Ellis, we have Andrea Lossi, who is the scientific director of the Sesame Light Source. And he's a physicist from Italy who has a lot of experience with hard X-ray, optic laboratory as well in Electra, where he has been working. And since 2020, you have been the director of the Sesame for the scientific aspect. So we have also in our panel, my colleague, Alan Hurd from Los Alamos, from the Forum of International Physics. He's also the current chair for the Committee of the International and Scientific Affairs of the APS, the CISA. And it's good also to have him for the question. But the panelists will be composed of further experts like Bernard Amadei, who is a French engineer, professor emeritus at the University of Boulder, but also the founding president of Engineers Without Borders, in the USA. And our first speaker will be Barbora Bruant Gulejova, who is from Bern University, working also at CERN, and responsible for the development, the former strategy development lead of the International Physics, Particle Physics Outreach Group, the former economic collaboration collaborator in Slovakia and at CERN for the teaching and science-based sustainability and innovation business. So this is where she's teaching now, but she has a background in thermonuclear fusion as a physicist and STEAM ambassador, and mainly she is the founding president as well of the Science for Sustainable Future. So that's the point and project that we will also come back to. So we have with us George Ellis, that we had introduced maybe a bit more last December. He's from South Africa. He's a cosmologist and have a long list of achievements with many books as well and wonderful collaborator as well. So from the University of Cape Town. So unfortunately, Rolf Hoyer couldn't be with us today. So being so representation of the CERN and the Sesame, because he's traveling, so couldn't get the bandwidth appropriate. So we will still have, so thanks to Barbora as well, his words. We have also with us, so Professor Amal Karsi, who is the chief of the section for the basic science at UNESCO in the research, innovation, and engineering section. So it's really an honor to have you with us. And last but not least, Michel Spiro, who is with us, so as an eminent also French scientist, president elected from the IUPAP since 2018, and actually even more now, but sharing as well the steering committee for this International Year of Basic Science and Sustainable Development, which just finished, so last December. So we will discuss all those potential aspects. So now with this introduction, so we will have, so Barbora and I who will ask the question after her short presentation. So I will let then Barbora sharing her screen and start the provocating question.
Thank you very much. Good afternoon, everybody. Thank you very much, Christine, for a nice introduction and invitation. It's my pleasure to open this very relevant forum and share with you some introductory observations and thoughts to provoke discussion and some maybe more thoughts, especially on the subject of how actually to raise the awareness of different stakeholders of the society about the role of science and physics for sustainable development. So actually, we all know that UN has agreed on Agenda 2030, which is described by 17 sustainable development goals, spanning from climate change to no poverty, etc., peace. And this is a very complex issue. However, it's also historically a unit point for the humanity and a huge opportunity. It's not about planet, it's about humanity's rescue plan to survive on the planet, which have been recognized on several events by important people like the former Prime Minister of France or the Minister of Science of Honduras during relevant events. So we do not only have to reconcile with nature, but also we have to transform our society. And this must be done in a different way than it was done before. So actually, if we look at how the situation is today, we could see that the efforts to solve SDGs are very spread everywhere, and they are thematically and geographically fragmented. What is needed is, and it's agreed that there is new global governance and sustainable leadership, new tools, diverse approaches, and to work together with all disciplines. So the issue is, and the question, like how to make all these actors, different actors, work efficiently together. So already before SDGs were born, we had these Millennium Development Goals. And it was clear since then that without the intervention of science, technologies, and innovation, there are not going to be solutions. And for SDGs, it's even more true. So it seems fine. However, the question is like, is it understood really, and by whom, and what is the real situation in the world? So we are going to try to think about this. So it's very clear, why do we need science for sustainable development or sustainable future? It's not only the technological solutions, but it's also data and evaluation tools to know if we are really achieving results which we want to achieve. And of course, science-based decision-making. Normally, this is something what majority of from the observations, which at least I have done, discussions with other colleagues, that it's kind of taken for granted that society leaders and scientists, they will somehow figure it out. But maybe it's not so easy. So let's have a look back in 2015 when SDGs were born, and this was basically the also moment when United Nations were celebrating 17th anniversary, and around the time that CERN, which is the only scientific observer to UN General Assembly, has been celebrating 60th anniversaries, and they've organized a very good event, a high-level symposium with participating high-level people from CERN, UN, different academia, industrial organizations, but also governments from 2 CERN host states. And it was entitled CERN Model UN Global Public Goods, How to Address Global Challenges. It was basically proposing how CERN works, that it could work also for SDGs, but I will get to that a little bit later. Now I just would like to point out a few things which have been discussed already in 2015 at that conference, like what are the issues with the implementation of UN agenda, which maybe was not that efficient as it was wished. So what was mentioned was lack of dialogue between scientists and policymakers. For example, Intergovernmental Panel on Climate Change has been described as a report which is just passed to politicians without too much communication, and therefore it results in decisions which are being taken with a gap. And how about today, 10 years, almost 10 years later, and what is the situation when we look at the health or energy? Another thing was a lack of multidisciplinary consensual decision-making. And here, this was not mentioned during the conference, but it's my own observation that when I checked, like, UN is implementing the SDGs through people who are called regional coordinators. And normally the eligibility criteria for these experts were international relations, economy, law, and social sciences. So we have physicists and natural scientists who are basically creating the understanding of climate change, etc. And then, of course, things which were mentioned were lack of rigorous, transparent scientific monitoring method to see how SDGs are really pursued. This is very complex, given that SDGs have been defined also with almost 200 or around 200 indicators of them. It's a complex system. And then there is not enough scientific literacy among the population, because we need them to collaborate if they want to solve different problems. So this is what was kind of criticized already in 2015. Now, the complex governance, which have been already working for 70 years, is something what we call epistemic big science model. What basically is the open global peaceful collaboration for common noble goals. For example, in the case of CERN, it's knowledge for benefit of the humanity. And we have there tolerance, neutrality, transparency, and as much as possible, no national limitations in terms of legal frameworks and political agendas. This is something what has happened to be then blueprint for other organizations like Sesame State or ESO, but also there is another nice example like World Weather Watch, which is the main tool for the activities of World Meteorological Organization. Not given that there was a very good success of this approach, so there have been in the past publications on the calls for multinational research efforts in different fields, like, for example, oceans, agriculture, brain research, and especially climate change. Now, this event in 2015 was basically proposing that this big science model could tackle SDGs. However, if we look now what happened, so not really much from those topics has changed till now. And these ideas haven't been really properly followed up. Why that is? I don't know. I would say that perhaps in 2015 that was not seen that urgent, but since then we have seen that the climate change, it's more tangibly seen in our lives. There was pandemics, war, so the urge to change is really there. Therefore, I was happy that in 2021 I got a chance to revisit that subject, and thanks during the UNITAR executive program on innovations in science diplomacy, I had a chance to organize the panel discussion on this subject with the CERN and its, let's say, children, Sesame, ISO, I myself representing International Particle Physics Outreach Group. And basically, with the very high-level speakers, we demonstrated that the model works, but also concluded that it's a really good idea to open the dialogue about using big science model for potential solution for SDGs. Here are just important quotes from that. I will let you see maybe in the article with that link from EPS. However, just few highlights. It was really highlighted that science diplomacy is a very important tool in bridging the gap between scientists and society. For example, that also we need not only diplomats doing science diplomacy, but also scientists in the politics. And for example, European Commission is very active on this field, and with several other panelists and stakeholders in that panel, like Sanja, and also Paul Bergman from UNITAR. We are now part of the working group of European Commission on science diplomacy. So we are going to promote these values for sure. Any input from the community would be very welcome. And then another thing which has been highlighted was the good communication of scientists, which is important. For example, to be able to warn public and society about climate change risks, but not scaring them. And this is also an important case for the school kids. So, as I mentioned already, we are in a historical moment here. Not only that for the first time humanity agreed to have kind of a common goal, this is Agenda 2030, but also the critical role of science to pursue these goals has been officially recognized by UN General Assembly, which represents about 200 countries, so the whole world. We have this thanks to huge efforts of IUPAP with Michel Spiro and UNESCO, because we just closed International Year of Basic Sciences for Sustainable Development and just entered to this beautiful decade, International Decade of Sciences for Sustainable Development, which is an amazing thing because it's a call for all the relevant stakeholders to actively promote coordinated, collaborative scientific approach, providing tools for informed policymaking and much more. So this looks really good, huh? However, we, scientific community, and then thus also all the world, are facing still some challenges. And first of them, which is very important in my eyes, it's the lack of interest from youth to study STEM studies, especially physics and especially girls. This is very counterproductive trend because the jobs are growing, we need them, and we already today do not have enough people to fill them, and also high-tech companies and tech physics-based companies do not have enough engineers already today in many countries. So really, we need to do something to inspire a new generation. And other problems are also mistrust in science. We have to justify, it's difficult to justify new large experiments, and of course, we talk about decision making. So why the physics actually, it seems to be misperceived in the society, kind of like complicated because it's different type of language, abstract, disconnected from anything what we do in the real life. This is the lack of awareness and the understanding. There is not enough scientific literacy, therefore there is not even appreciation. And we can actually trace this back maybe to the scarce exposure to modern physics and tangible value in the life. And what are the easily accessible sources of information, or sometimes missing information, not complete information? So everybody gets information in school. And if the curricula are not up to date, so of course, we don't get the full picture. Just an example, when most of the students, when they finish high school, they still think that there are just 3 elementary particles and 2 types of forces. And we know this decades ago that it's not true. And then, of course, there is a problem with the media, if it's social or mainstream, and there is a lot of misinformation and disinformation easily accessible. Society is very complex, and everything is interconnected. All the communities are relying in one way or another on each other, sometimes we will even without realizing that. And however, these are most of the time silo communities. And this means that they do not really talk to each other, or they don't know how to talk to each other because their language is so different. And if we have a look, for example, at the science community, so there is also a lot of silo communities within scientific community. So the dialogue is really the key. Let's have a look at the role of how it's perceived, the role of the sciences for sustainable development by the different stakeholders of the society. I will take the example of CERN because that's a great example how physics is really contributing to the sustainable development. So first official mission of CERN is scientific knowledge. However, there are more. It's also driver of innovations, knowledge transfer and economy, and they collaborate with industry and create a value of a society in many different fields. Here is just a snapshot of many applications, but there are much more. And also, as we already mentioned, it's an example of great peaceful international collaboration. And its fourth mission, it's education and outreach, because thanks to any stay at CERN with any duration, there is a steady stream of highly qualified people, and 80% of them are employed by industry and business. So 2 years after SDGs were born in Geneva, there was an event which asked all the international organizations to present how they contribute to SDGs. So I was with colleagues from Knowledge Transfer Group, we prepared content for that and presented it. And basically, it was clear that just by following its mission, CERN contributes de facto to at least 5 sustainable development goals, and directly, indirectly, probably to all of them, because also since 2015, there was a lot of progress in knowledge transfer. And basically, main outcome of all this was that the CERN contribution to SDGs was positive surprise for all basically the participants, and because its impact on the society and tackling SDGs is still widely unknown to the public. This is the conclusion in the article which we have written about the event. This could be mapped on the whole physics and science community because the awareness is still very rudimentary. If we have a look at the UN policymakers, etc., so this was already mentioned, taking example of the regional coordinators. However, we could also ask how many countries have really the official science advisors in government? There are a few, but not all. And if we have a look at the schools, so at least in the countries with which I'm in contact in European Union or Switzerland, so it is sustainable development, it's obliged to be taught in high schools. However, as there is a lack of materials, so this is happening only during classes of geography and economy. And then students, as they are not taught about sustainability on basic science language, basic science lessons, they automatically situate sustainable development outside of physics and STEM or STEAM, which is a pity. And then not only that physics is misperceived, as I mentioned, but also global challenges, especially climate change, are presented as very scary to them and not as something that they have a huge power to change that. So let's have a look at the industry and what is that role in sustainability. Of course, industry plays a huge role because that's basically through knowledge transfer and technology transfer, the path from research to real citizen, because that's the innovation path. You get the idea from academia, and through industry, it becomes the real product. This provides the context of how science is present in our everyday life, society, and for all the challenges which we are going to solve, and also career opportunities beyond academia. These things are very powerful and attitude changing, but largely unknown. And industry is in a huge need for the future employees. As already mentioned, most of the scientific employees would go there. And I would like to mention, for example, that it's also not very well known that physics contributes very largely to the economy. This has been proven recently by great reports from EPS, European Physical Society, and Swiss Physical Society. And for example, in Switzerland, the physics-based industries are the second largest contributor to Swiss economy after finance. Big surprise for many. And another thing, a lot of industries has to do something with sustainable development because there are official policies like corporate social responsibility, etc. However, they are sometimes so much concentrating on business that they do not really realize that how much they contribute to the society thanks to collaboration with science. And this is something which is extremely inspirational, has great potential to inspire young people. Sorry. And now, how about scientific community? So from my observation in the last 10 years, especially, I was working really in outreach, communication, and education. So I'm asking, are we really proud enough and aware and proud of our contribution to the society? I have seen actually the kind of resistance to communicate our impact. Not only that, oh, we are curiosity driven, and of course, that's the basis, but we also do a lot of good things for the society. And then maybe food for thought, sorry. Maybe something could be done even more in also other research bodies and organizations following great example of accelerator physics community, like the example of CERN. So we are really in the time of the huge opportunity to create the dialogue. Because SDGs, you might have already figured out from what I said, it's the access entry point, it's strategic entry point for scientists to enter the dialogue with all society leaders. If we look at the current leaders, they all want to talk about SDGs. And also to future society leaders. It's even a good time to adapt school science curricula and inspire all the generation about the value of science, because in many countries, education systems are now changing, and they are implementing new things like connection to SDGs, multidisciplinarity, and career options. So, and scientists actually, and also the science-based or physics-based industries, they have very important role to play there. Nobody can inspire better. So you have already understood that really education, in my opinion, is really the key to change and to change the paradigm for sustainable leadership. And the important is that we have been educating, or what is the status quo today? It's more or less educating for the past, but it's important not only to stop that, but also take the lessons from what worked, what didn't work in the past, and create new education for the future. Today, who is deciding about education? It's current society leaders. And the youth who are receiving it, they are future society leaders. It's not just students, it's future society leaders. And some of them would become STEM specialists, physicists, etc., to create the technologies, innovations. But most of them will be not scientists. But for us, it's important that they are scientifically aware citizens, because this is what is the key for sustainable leadership. And last part, just how could we maybe better or in the most efficient way establish this dialogue? So proactivity, it's very important. Who will be our ambassadors if not us? Here, I would like to really highlight a few shining examples like Herwig Schopper, Rolf Hoyer, and Michel Spiro, and others who haven't been waiting for invitation and just really did the right thing. And now we are all talking about these great achievements and want to follow it. We have something to follow as well. So, another thing, I am now following what George was presenting last time in December, that also the dialogue, it's about respect. It's not that we are smarter than the others, but we have to be kind, listen, and really to be interested about interests of other groups and of stakeholders and their views in order to efficiently work together. And then, of course, multidisciplinary cooperation and dialogue, and the language. The scientists have to make efforts to adapt their language to the language of other people with who they speak. And for example, context, as was already mentioned, with real life and storytelling, it's something what really works well. But there is a lot of efforts to where we have potential to go and follow up on that and create great resources on that. And then, of course, choosing strategic information and data for the strategic people who can make change is also a very important thing. So, I'm sorry, here are few thoughts to provoke discussion. And I can just say that I have implemented these rules for me and tried for changing or adapting the education system, first locally and then internationally, through the project I developed, which I called Youth at STEM for Sustainable Future for high schools. And I can say that it really works. Thank you very much, and I'm looking forward to the further discussion.
So thanks a lot, Barbara. So it was a very good summary from last time, but also presentation with a lot of insight and looking at as well how the younger generation as well can participate. And indeed, for transforming, I think the word that adaptation is really good, but indeed transforming the education is a good way forward. So we will start our question. So we see that we have a question and answer already. So this little box that you have at the end of your screen, so you can feel free to add your own question. So we have one that will certainly come as well for George, so to be answered, because I think it's very related as well to the presentation that you gave last time. So maybe we will start by that one. It's a good way as well as a transition. So question and answer from Anonymous, but I think we respect as well Anonymous. So is the effect of the nuclear science in sustainable development. So maybe a short summary of that based on what you presented last time, George. Nuclear science.
Yeah, I strongly believe that there is a great future of nuclear energy. I think that we've had some scares, and those scares were in a couple of cases where it wasn't handled properly. But France, for example, has really, really good nuclear energy for many, many decades, no problems of any kind. There's been an emotional reaction against it, and there have been these one or two incidents, but the modular pebble bed modular reactors are a very good way to go. So I'm like Václav Smil in favor of nuclear energy as being part of the way to go with sustainable development goals. And I'm driven in this particularly by driving up north of Johannesburg towards the Kruger Park, and you spend 3 hours driving with the sky black with smoke from the coal-powered power stations in that area, and you can see the devastation of the atmosphere taking place when you do that.
And I copied the climate somewhere as well, all the way north in Denmark, where they also have the same policy. Yeah, but no politics. We try to find solutions for them. So one more question. So now we would like to have then from our panelists, so Bernard, maybe taking the first question. So based on what Barbara as well was presenting and on what George as well mentioned last time, the concept as well or the major risk as well, which is misinformation. So it really creates a lot of entropy, so to the system. And can you describe a little bit the source of misinformation and the possible mitigation as well to lower this complexity that George was mentioning in December?
Okay, just give me 1 minute. I'm going to load my short PowerPoint presentation there. Yeah, before I talk about misinformation and disinformation and infodemic, which is the term there, I just want to advertise a new book that just came out on looking at the complexity between peace, sustainability, and climate security, where I looked at using systems approach. How those three are interconnected. You know, you cannot have a sustainable world that is not peaceful, and that is climate secured, and so on and so forth. So in this book, I look at the again interaction between those three domains, and how do we? What are the indicators of peace, sustainability, and climate security? In case of sustainability, we can certainly use the Sustainable Development Goal, and we have to remember that when we talk about misinformation and disinformation, it's part of a bigger platform here, bigger set of problems that we are facing that planet Earth has never faced before. People talk about the VUCA world. Misinformation and disinformation takes place in a world that is volatile, uncertain, complex, and ambiguous. And obviously, those characteristics are quite difficult to handle, especially if, with using traditional science and engineering, which is based on the work of Newton and Descartes. The idea of deterministic approach. The deterministic approach falls apart essentially when we deal with complexity. So a question that I will raise later on is about the education of scientists and engineers to address essentially the world issues in the 21st century. There are many of them, and we know quite well that those issues are interconnected. So if we just the approach of looking at the world and like we do in universities, a bunch of vertical silos, when most of the problems are horizontal, that approach essentially doesn't work and needs to change. So SDGs, essentially, I just want to, that's been the platform that, as Barbora mentioned, that countries in the world have accepted. I'm not against the SDGs. I'm not for the SDGs. I'm kind of taking the lukewarm about the SDGs, and I will tell you why. Because essentially, I'm an engineer, and I work in developing countries around the world in small communities. The SDGs are great, or maybe are great, have been developed at the national level. When it comes to the local level, they are quite useless. At least that's my perspective from an engineering point of view. So needless to say, it's nice to have goals, but at the same time, one has to be careful about the scale of the SDGs and the context of the SDGs. Applying the essentially this SDG platform is different at different scales. And I think that the SDGs are missing the issue of scale, and also missing is in the SDGs are the ethical standards that people need to have in order to address the SDGs. Ethical standards are critical, but they have never been addressed essentially with the SDGs. Yes, we can provide water to people, but is it done essentially in a respectful way? Is it done essentially, is it good for the environment? Is it good for the planet? Does it create partnership? Does it create peace? Does it divide people? So the SDGs there are good. Hopefully there will be something after the SDGs in 2030. We are not there yet, but at least it's a roadmap that we need to follow with essentially some questions. Let's put it that way. Bottom line is for me is, yes, SDG sounds good, but the bottom line is you can look at 17 SDGs and 100 plus indicators and targets. Fine, but the bottom line, again, from a perspective, my perspective from an engineering point of view at the local level is always ask that question, what's the role of science and technology and engineering, making sure that all humans have fulfilling lives, meet their basic needs, and live with dignity and at peace. And we are far from being there. So misinformation and disinformation, what we call the infodemic, is here. It has always been here, but because of social media and social platforms, they're spreading like a virus all over the world. There's a difference between misinformation and disinformation. It has to do with intent. Misinformation is written here in red, is essentially false or inaccurate information that is spread without the intention of deceiving others, whereas disinformation, there's an intent essentially of manipulating people and essentially creating essentially division, which can be quite harmful. We have, I think the world has experienced many of those issues of misinformation and disinformation. And look, for instance, at what happened in Rwanda in 1994. I mean, that's a really good example, a bad example. An example of disinformation where essentially using social media, at that time just radio, people were able to convince a group of individuals to kill about essentially 900,000 people in 100 days. So we've got to be extremely careful about misinformation and disinformation. And here are listed essentially different in blue, some different techniques and solutions that have been proposed in the literature to deal with misinformation and disinformation. We are really essentially inept essentially at dealing with misinformation and disinformation today. And we know quite well that misinformation and disinformation can threaten essentially human development and security, and essentially can lead to conflict. And we have many, many examples essentially that we need to take extremely seriously. Here's some survey that was done. People may not know about the SDGs, but I think more and more people are becoming aware, especially here in the United States, about the role of disinformation and misinformation in essentially contributing to potential threats and in different places in the world. Someone had, not my own experience, but I know of someone who essentially was completely discredited by somebody else. Just you go to Pakistan, you pay some people in Pakistan, and then you ask them to write a series of articles essentially to discredit somebody. They will do it for free, or they will do it for some money. But the bottom line today is actually quite scary, where science and technology can create misinformation and disinformation. How does the misinformation and disinformation look like in a bigger picture of risk? This is a picture taken from the latest global risk report from the World Economic Forum. I show here with the arrow there, essentially a little blob on misinformation and disinformation. You can see here that the risks are divided in 5 categories: economic, environmental, geopolitical, social, and technical. There, misinformation and disinformation does not stand by itself. It is connected to a lot of other risks, essentially, and those risks are essentially feeding into misinformation and disinformation. So where do we, again, using a systemic approach, which has been my approach now for the past 20 plus years, where the question is, where do we intervene in the system? Do we intervene here in that blob of misinformation or disinformation? Or do we intervene in the issue of erosion of social cohesion, knowing that by doing so, we are going to affect misinformation and disinformation? Where do we intervene in the system? Where are our leverage points? Excuse me, when we address misinformation and disinformation? Do we need to look at the green issues here that we know somehow are connected to misinformation or disinformation? Or do we address misinformation and disinformation right away? I think a systemic approach is key to addressing essentially the Sustainable Development Goals and making sure that the Sustainable Development Goals essentially are met sooner or later. I just want to bring you to your attention a new platform similar to the IPCC. IPCC has dealt with climate change. This platform was created by 2 colleagues, Dr. Howard from Oxford and Dr. Himmelfarb from the Peace Tech Lab in Washington, D.C. This essentially platform, it's based, the institution IPIE just opened an office in Zurich, Switzerland. And the goal here essentially is to, again, address the different aspect of misinformation and disinformation. Again, where do we intervene in that system? Misinformation, disinformation is here to stay. So how do we educate essentially people to make essentially to become aware of misinformation, disinformation? And I want to bring to your attention the latest report that was published in 2023. By the way, if you're interested in becoming a scientist affiliated with IPIE, you can go to the website and essentially register. The goal of the IPIE, like the IPCC, will be to create essentially committees, working groups, essentially at the international level, to fight essentially the cancer of misinformation and disinformation. I think that's all I'm going to say about misinformation and disinformation. Maybe people have questions about it. It's big. As Barbora mentioned, as scientists and engineers, we need to denounce it and we need to do something about it. We cannot stay on the sideline. It threatens people, but especially poor people in the world.
Yeah, so that was really well presented. So you had worked out. So we really appreciate that, and I think it was excellent to have possibility to understand and to have the link. So I put the link as well to the HEP as well. That was I think a big channel, a big panel where we could and everyone could participate. So maybe now we'll have, so yeah, Barbara, with the next question.
Exactly. Thank you very much for this. You know, I really appreciate your thoughts and information on this. Maybe just for this education role in this information for the future generations, I think the critical thinking, teaching critical thinking, it's really a very important tool, how in the future people could figure it out themselves and not believe everything what comes from easy accessible sources. And there could be a lot of things done for that in the future. I would like to follow up on what you said about systemic engineering, etc., what you have been doing, and I would like to ask, how actually do you think could science and engineering and industry contribute to the systemic change and especially to solutions of these global societal solutions? And maybe if you can even collaborate on some possible test cases, that would be really interesting.
Well, thank you, Barbara. I think that's a really big question. How do we train? Essentially, it starts with education. I've taught engineering for 40 years. I'm semi-retired now. And the key question is, how do we train essentially young engineers and young scientists to address essentially problems? So that, again, the big picture is this one here. That's, to me, that's the ultimate, that's the outcome. I know we are not there yet, but as scientists and engineers, we make essentially decisions that affect millions of people, and we need to keep essentially the goal of our roadmap in mind when we essentially practice engineering or do education and so on. I mean, the key question that I've been asking is, do today's engineering and science graduates, educators included, and practitioners have the skill and tools to address the global problems that our planet and humans face today or will be facing within the next 20 years? The answer is no, plain and simple. Essentially, our model of education is still based in the ancient approach, deterministic, essentially, model of Descartes and then Newton, when essentially the problems that we are facing cannot be divided into parts. We cannot just look at each part of the problems and say, okay, now we solve the entire problem. Those essentially issues, as I mentioned earlier in the previous diagram, showing misinformation, disinformation, are connected to something else. The 17 SDGs are not 17 boxes, essentially, that need to be addressed by experts. But there are many essentially connections between the 17 SDGs. Look at the issue of water and energy. I mean, always my colleagues who love water and say, we provided water to a small village in Africa. I say, fine. How are you going to move that water? Water at the bottom of the well stays at the bottom of the well unless you look at energy. Where is the energy? Okay, what are you going to do with the wastewater? What's the relationship between water, energy, food, and land? So, I mean, those essentially big questions are not academic questions. They are essentially that's what keeps people alive by the end of the day. And we need to remember who we are serving here as scientists and engineers. Who are the clients? The clients are the 8 billion people who this morning woke up and then try to essentially, for 3 or 4 billion of them, is they're trying to stay alive by the end of the day. What's the role of science and engineering in addressing the needs of people whose job is to try to stay alive by the end of the day? Academic papers will have no influence whatsoever. I'm proud to be an engineer because as an engineer, I go to the field and do some real work there. But again, how do we prepare young people to address issues 20 years from now that we don't even know what they are? And they will be using tools, essentially, that have not been invented yet. But some of them have been invented, but there will be some new tools that will be necessary to address the problems of 2030, 2050. So I think we need to change the way we're educating essentially young people today. It's how they're going to be essentially leaders in addressing those issues of the future. And we don't do a good job at it.
And we need to transform this education. I fully agree. One of the key aspects in the work that you do, so beyond being on the field, Bernard, so which is like a really important engagement to be directly with the people to understand their culture, because the culture is different everywhere on the planet. So it depends on how to address what's the best way. But as well with all the different work that you do with the education, for instance, in South America. So can you give some example there and in Uganda, how and what do you do concretely? And I remember the example that you were mentioning in terms of how in the case, it was in Rwanda, how they are following up as well. So to just to have one PhD student graduating, he will have in different years to go and looking at a very specific problematic. So I like this idea to get something concrete that could give ideas as well for all the other professors. I see that there are a lot of professors as well that are listening, how to find ways at the higher educational level for those that are ready to transform as well the society, to give a possibility. And then we'll come to the high school and to the younger generation with Barbora.
No, I mean, that's an open-ended question. That there are many questions within the questions there. I mean, again, if I look at this diagram here, again, how are we preparing people to address the issues of 2030, 2050? It's not going to be, we know quite well, it's not going to be using the traditional model of education. In fact, I think one thing, we need to stop talking about K to 12 education. We need to talk about K to gray education, gray being gray hair. It's a lifelong type of education. How do we prepare young people today when they graduate to endorse lifelong education, where essentially they are able to maneuver as new problems are arising and as problems are being solved? We don't do that. I mean, one model of education, again, you mentioned Rwanda. It was a model of education. If I were a dean of engineering, here's a model that I would use. I would never be a dean of engineering. I avoided it for the past 40 years because I have no patience whatsoever with academics. But anyway, let's put it that way. I mean, a model of education that I found probably the best one is in Rwanda, where you essentially send some young engineers to the field first. They don't go to the classroom and open some books. They go to the field first. They essentially adopt a community. It could be their village or village that is being assigned to them. Then each year, and then after that, they come back. Second semester, they come back and they open the books. So now they can look at what the books are saying, what academia is saying, how to address the problems in the village they started with. And every year, they go back to the village. And at the end of 4 years, essentially, they have to write a thesis showing how, using science and engineering, they have improved the living conditions of the people in that community. That, to me, is probably the best model of education you can think of. Again, it applies to engineering, right? I mean, science, you guys may have a different approach. But, how do we educate doctors? There are schools of medicine there where essentially they send the students first into the hospital first. And they look at books in between. They don't look at books first and go to the hospital next. They essentially deal with patients on day one, of course, with some supervision. But then they learn the ropes, essentially, of medicine by doing, instead of reading book. I think it's time to stop education as schooling, and we need to replace it as a learning experience for life.
Very good.
How do we do that? It's a bit different. And I think the approach is an underlying approach is to essentially use a systems approach. And I love this diagram because it really shows typical academia there, where people believe that the world essentially consists of linear A to B, relationship. When someone opens the door and decides, oops, it's a bit different from what I think the world looks like. And now there are some people who keep the door open and jump into a system science and system thinking. And there are some people who close the door and are preferable love to stay in their labs essentially and think that the world is linear. So this diagram here is, I love this diagram because it's kind of a reflection of how people approach for instance, the SDGs are all outside there. And you have a bunch of people looking, well, one SDG at a time, and let's see if we can solve it without taking under consideration the other one. When we talk about the SDGs, I think another way of looking at the SDGs are the 5 Ps of the Sustainable Development Goals. When I do projects, ask the following questions. Is my project good for the people? Is my project good for the planet, the environment? Is my project, does it create prosperity, not profit? And does it create partnership, creates business? And ultimately, does it divide people or it brings peace? If those 5 Ps are there, I go ahead. If one of the 5 Ps is not there, I try to essentially increase capacity. And if it's not possible, I don't take the project. How do we?
This is really like the complete answer. But then back to what you were saying before, I would like to have Barbora as well, looking at how, in her case as well, looking at the school aspect. You were speaking about the school project and how, with respect to what also was discussed with Bernard, with the industry. So which type of approach? Because there, what is important, indeed, this is to train the leader also for tomorrow. A lot of them will be in industry. So Barbora, how did you look at this as well in terms of test case for addressing as well the science and society?
Mm-hmm. Yeah, thank you very much for the opportunity to give a few insights of that. I would like to share actually a few slides, but for the moment I have to wait so that Donna stops sharing. Thank you. This 5P approach, it's exactly what is needed for sustainable leadership of the future, right? So this is a very holistic way.
Well, it's not just holistic, it's the nature of the beast. I mean, if you look at the world is not made out of vertical silos.
Exactly.
Only in academia do we have places where we have vertical silos. So I think that, that's my take. Sorry.
Yeah, I fully agree. And I just wanted to mention that you mentioned that the new generation have to tackle things differently and we have to teach them how to do it. So OECD has put together the set of skills for the future. And I think this is, and one of them is, of course, critical thinking and a lot of things which we usually don't teach, multidisciplinarity, etc. And so these are the trends in the education for the future. But in order to get there, there are a lot of effort and there are multi-stakeholder efforts. So I have developed this program, which is called Youth at STEM for Sustainable Future, which I actually like to say addresses the problem which I call SDG 18. It's this lack of interest of young generation to become future generation of scientists, but also to be scientifically aware. This is counterproductive, as we said, because we really need the students, so I don't have to repeat that. The reason why all is so misperceived is basically if you look at the very classical school curricula in high schools. So what they teach there in about science and physics, disconnected from real life, from current science knowledge, and also from science societal challenges that we are facing today. There are a lot of programs, outreach programs, which are really amazing, but often they have the context, which is basically, content, which is very technical and the nature with like teaching classical things in physics. And that's interesting for already what we can call converted audience or usual suspects. So those who always wanted to become physicists, they love it. But the rest of the classroom is left behind. They don't see what is it good for. And then another issue is that with the outreach programs, which are not officially part of the school curricula, we reached a limited number of students because it depends on a handful of motivated teachers, like those who are coming to CERN teacher programs, etc. But even them, if they get really inspirational content, they are sometimes and often frustrated that they cannot implement it in their classrooms because they are limited by the time and capacity they have to teach what is in the curriculum. So it's not enough to do that, to produce the content, but we also have to have the way and policies to implement it worldwide. And I mean, in the curricula, otherwise it's a question of few schools who have a chance. So what actually really works? It makes sense, just a common sense, but I'm very happy that it has been recently proven by a PhD study at CERN University of Vienna, but also other publications and studies, and of course, different pilots, etc. That what really works to raise the interest of students, high school students in physics, is the context. It's the context with the real life, humans, nature, our universe, and societal challenges are really very good way how to create the context. Then, of course, it's all these applications of the modern science. And then what really works, there were also studies on that, and it works especially for girls, that it's contribution to the society. The new generation really wants to contribute to the society. So it's important for them. Therefore, SDGs again work perfectly. What is the avenue of education which haven't been explored so far, and which I also mentioned that industry has a huge role to play there? It's to include industry, because industry really is presenting, showing the science in action in everyday life for well-being of the society, all the technologies which we are using, etc. And the approach has been recommended by ECFA in 2018 based on what I have proposed for Slovak government when I used to be industry liaison officer at the time for Slovak industry with CERN. Actually, what is the strategy to make a really huge impact and not to just do the project which would reach to 1 or 2 students or a few countries, etc. Strategy is to first go beyond the converted audience. We know now how it works, and then to integrate it in school curricula. And this means observe the trends, work with educational authorities, and align what we are proposing with the educational trends which they are working on. And as I mentioned, multidisciplinarity, SDGs, and career opportunities are the keywords, at least in Switzerland and other countries which are now really being in the new education plans in development, following basically this OECD new skills system. So Youth at STEM for SF is really the working example. It's the first of its kind school program which connects the science with society and sustainability and includes the real life experience through industry and using scientific role models, both genders, from industry, from science. It is what we call wall classroom approach, because it's especially for those who are not always wanted to be scientists anyway and who understands the value of science, but for all the rest, 99% maybe, I'm too bad now. And target groups are actually not so students which are talented at STEM, but are hesitating, especially girls. And then all the rest of the class from the future society leaders, who it's better to have them ambassadors for science than somebody who just didn't like science in a school or physics, and therefore when he becomes a decision maker or working in funding agency, he will make the decision accordingly. So this is international concept which have been developed during the last 5 years with multi-stakeholder international community, with a lot of knowledge partners from academia, the communities on the interface between science and outreach education, between science and business, big science and business, educational authorities, teachers, science teachers, physics teachers themselves, and industries themselves. In order to make sure, you know, that if something is proposed, everybody likes it and it makes sense to everybody. And so first, it was approved by multidisciplinary experts from several countries. We called it 4S Plus because most of them were started by S, but there were more. However, as it's usually better is to do the pilot in one country. So last year, there was a proof of concept in Switzerland, thanks to these partners. And it was in a gymnasium working with the 2 companies. We had 55 students, 3 teachers from different basic sciences collaborated, and scientists and engineers from both genders inspired them. It is basically what really is fitting in the current trends of the teaching, thematic day plus follow-up. First, it's inspirational lecture from scientists about, not about typical science subjects, but about how does it matter in your life. Different examples and different career opportunities, which they can really do with this physics diploma in their pocket, even to work for L'Oreal, for example, because to develop the cream or anything, you have to have scientists, physicists, and chemists. Then it follows with excursion to real tech company, where you can see that in life. And then you explore also the different fields of that company, how it connects. So what kind of skills do you need if you want to solve the problem in that particular SDG or environmental, energy, health, etc., depending on the company which you can visit, which is in the vicinity of your school, of course. And then it continues with the prizes, working on it officially also within the program of the maturity. And you can get, as there are two audiences, one of them is those who always wanted to be scientists, or those who want to become scientists, I want to say, and they would get internship in a tech company. But those who want to be future society leaders, they would have a chance to give a speech at the UN Youth Forum about the role of science for sustainability, which, and then you hit the two goals, because not only that it's good for the person to have that in CV, but usually in this kind of forum, we would never really speak about science. And peer-to-peer communication, it's much better than if some high-level people come there and speak to them. It's better to have it among students. So the results have been measured, of course, to have data. And the first results are very good. So 30% of students who never envisaged to study sciences are now thinking about that seriously. Most of the girls find physics very much accessible thanks to the female role models, which they didn't see before. And 50% of students who are not going to become scientists, they want to be ambassadors for fact-based informed decision-making and scientifically aware. There are some nice quotes as well that really prove that students, it's open-minding. I mean, yeah, it's mind-opening, sorry, that they realize that science is much more than what they just see in the classroom. And what is the most important is that it was really, given that it was done with the collaboration with the Swiss authorities, which have been also one of the pilot sponsors. It was recognized as and a great example of pioneer program, which is already now implementing the new Swiss high school education plan that will be implemented only later, but we are working on it. And this project was really highlighted as the one which is really ticking everything what they want to do there. So this is the first step, how to then the strategy is to do more, scale up, and having more data, so cantons will really officially implement it. And also this is a very historical moment, because as you know, Switzerland has 26 cantons, and every canton usually does what they want. So it's a very hard case to implement something nationally. But now, historically, it's for the first time that the new education plan is going to be nationwide. So there are still steps ahead, but it's going in a good direction. This is the scale-up plan, the last one.
Just to interrupt, because indeed to scale up and to try to understand, because I would really like to hear as well, looking at the developing community as well, or looking at how George potentially could comment on that. And as well, just to mention that anyone can raise their hand if they have during the presentation, also during your presentation, some question. And we need to potentially as well make sure that everyone will bring as well the insight. So go ahead, Jen.
So I continue just to finish, right?
To finish this, yes, and I would like to hear indeed from George or the others.
George. Absolutely. So the plan is to scale up in Switzerland and internationally. And for this year, actually, there will be the first international pilot, which will be as a pre-event of the Big Science Business Forum, which will be this year in October, thanks to the collaboration and support from IUPAP and Big Science Business Forum. And then it will be also tackled during the EPS Forum, which is the connection of European physics and industry community, with aim to create the network of the industries to support that, to ambassadors. And in the same time, there are collaboration with different universities to based on the inputs from the program, to create the database of the new high school education resources that would connect science with SDGs, exactly the missing ones. Thank you very much.
So thanks a lot. So indeed, that was really a lot of great information. Scaling, I think this is important, geographically as well, and then from the different level of education. So we saw from higher education to the youngest one, how we can as well, now depending on the culture, depending on the country, have the best way forward. So indeed, I just wanted to think back in terms of what you presented as well, George, last time. And I think it was really interesting to see how, what do you think in terms of this was the case in terms of Switzerland? Would it work somehow in other countries in Africa? And maybe we can have Amal as well thinking on that way forward. So what do you think of while looking at that way? Any lesson learned from also, George, what you said last time, looking at this presentation? So from Barbara?
I wanted just to say two things. I think that we have been, in a sense, a victim of the success of fundamental physics in terms of public participation. Everybody gets a lot of stuff about how important fundamental physics is, and of course, a lot of you guys are at CERN and so on. And what we're missing is an equivalent thing from the applied physics community, and they just are not as successful in engaging with public engagement. And what I would like to see done, and this group could be in a position to do it, would be a little booklet or presentation saying scientists who have changed your lives. And it would be a really interesting kind of presentation. I would refer to John Bardeen, to Charlie Towns, to Alan Cormack, and these people, and put it together and say to the world out there, do you know that these people have changed your lives? Do you know how they have changed your lives? And the chances are most of them won't know. For instance, that Alan Cormack started the CAT scan, which has revolutionized medicine throughout the world. Charlie Towns invented the laser, which has transformed huge amount of stuff. John Bardeen, the transistor, which has absolutely changed life. And so I think a group like this could produce a little booklet or something, which is, as I say, the title, it's for scientists who've changed your lives. And this is a completely viewpoint from that. And the other thing I'd just very quickly like to share one slide here, which is this one. And this would be, do you know that just because the world is warming doesn't mean it won't get colder where you are? And this is the nonlinear thing, the stable polar vortex, and so on, the unstable one. And this shows how you can get things going warmer even though global warming is taking place. And this is the kind of nonlinearity which needs to be explained to people out there. And it was that lovely diagram showing that the real world isn't linear. This is an example of it. And we need examples like this of how counterintuitive behavior arises because of the nonlinear way the dynamics of the real world works. So those are the two things that I wanted to share.
I fully agree with you. Just one note, this the project is not about fundamental physics only, but it's about science, which is applied and fundamental. Anyway, with industry, they just work with applied physics. So it's all together, of course. Yeah. And this book effort, it's a great idea.
But you see, what George was presenting, this is exactly what we need. By connecting all those different persons together, you see, we have concrete example of what we could ask. And I will right away ring the phone in Fermilab to try to get some of, John Bardeen and those different persons as well in line. Because I'm sure that if we can collect that, it would be something really important. And then also to remember that we have this year, the 70th anniversary at CERN as well. So for the case of high energy physics, but as well as an ambassador for science in general, high energy physics and particle accelerator as well one way forward. So I think it's a good year to celebrate And it's also a good decade to do something that will really sustain for the generation to come. So the youngest kids that you are teaching to all the way to the oldest one. So, and I think that this is exactly what Amal certainly. So please go ahead and make sure that also you voice everything that UNESCO is doing. So we wanted you to hear all those different ideas as well, so that it could be as well a melting pot for you to be able for those activities as well to build on. You see, we're trying to bring some material as well. And this leaflet would be a really good example. So thanks, George, for the idea.
Thank you very much, Christine, and thank you, Barbara, for the presentation. Great ideas. I actually want to comment on one thing you mentioned, and I'm sure we will discuss more about it later with you, because we have a STEM program, and for the past few months, we have been discussing actually how to develop this program and how to develop a new strategy for STEM. And from the internal discussions, we found that it's very important to come with a clear definition, because we found that until now, sometimes people have different concepts of what STEM is. And for us, STEM is not only about teaching the basic science subjects in the schools, because this is what is already happening in all the schools around the world. Okay, there are some differences, of course, and we know that some need to be advanced more, but the students in the schools, they study physics, they study chemistry, they study math. But we cannot say that this is a STEM, because then it wouldn't make sense. STEM for us is actually something that Barbara mentioned, which is how to critically think. And this is what we want to promote during the STEM, through the STEM program. It's very important to equip the students by tools to scientifically think. And in the end, actually, they don't have to go to study science or math or physics or math or chemistry. They might go to study law or literature or anything else. However, they will be equipped with these methodologies and tools to criticize, to think, to judge. This is our aim that we are trying really to build our new strategy to achieve. We are still internally discussing. However, I'm sure it was very useful actually to be in this panel and listen to Barbara. I'm sure we will discuss more with you on how to advance in this, especially in certain regions around the world. So this is just a quick comment. Thank you very much.
But a very important comment. So thanks a lot, because indeed that's the idea for this decade as well. Huh? So if you could maybe describe a little bit more, looking at the regional all the way to the national and the international, how all those display will be able to be implemented. So Amal.
Okay, so very quickly, of course, just as a general background, United Nations has a history of declaring international decades to focus global attention and efforts on specific issues. And these decades usually aim to mobilize international cooperation, raise awareness, and implement also concrete actions to address major challenges. We are facing major challenges, as you all know. And if you may allow me just to give very quick introduction, and I'm really happy that Michelle is here, because the decade basically is a result, is one of the important achievements of the International Year of Basic Sciences for Sustainable Development. And we are very grateful for our partner, IUPAB, International Union of Pure and Applied Physics, and Michelle, and also Serbia, for bringing this to the attention of the United Nations General Assembly when where it was proclaimed last August, the decade, I mean. And UNESCO, as a specialized agency, actually maybe the only specialized, not maybe, it is the only specialized agency with a specific mandate for science. It was entrusted to lead the decade, and we are working very closely now with our partners to have a concrete vision and plan on how to implement this decade. And the objectives are emerging from the major challenges we are facing. And these challenges were mentioned by Barbara and by all the eminent scientists here, promoting science literacy, ethical production and application of actionable scientific knowledge, advancing global basic sciences. The decade is not only for basic science, it's for all sciences, which is something, it's a step ahead from the international year, and also infrastructure of open science, creating multidisciplinarity. All these are major challenges that we hope through the decade we can address. Now I come to your question about how the regional examples of regional coordination and the network to achieve the objectives of the decade. The Sustainable Development Goals ranges of course from ending poverty and hunger to ensuring quality education, climate action, all these things. However, they are very complex. I mean, the complexity of the goals requires strategic and region-specific initiatives. For one reason that was mentioned by the eminent speakers here is the difference in culture. Regions are different, countries are different, and we need to respect these differences. In fact, it can be advantageous to use these differences to develop better plans on how to achieve the SDGs. There are several examples of how UNESCO use regional networks, which is the Unit 1 UNESCO Chairs program. Last year we celebrated the 30th anniversary of this program, so it shows how successful it is. It's a dynamic initiative by UNESCO. It serves as a global nexus for universities, promoting knowledge exchange, interdisciplinary research, and capacity building. So basically the program orchestrates partnerships and networks among universities worldwide to emphasize the collaboration to address global challenges. And basically the chairs are scientists embedded within universities, and they function as hubs for research, education, and innovation, with a focus on advancing sustainable development. So actually they play a very important role in achieving the sustainable development goals by encouraging regional collaboration, by facilitating exchange of information, by building institutional capacities and human capacities as well. And for us, the UNESCO chairs are very important tools because for us they are the experts. They are the advisors. We work with them to deliver hands-on training activities, for example, and they advise us on the different activities needed in order to achieve these goals. So this is, for me, it's a very important example of how the regional and yes, the chairs, we have a big network, a huge network. In fact, only in basic science and engineering, we have 60 chairs around the world. And then they can form what is called Unit 1, which is basically a group of chairs from different regions, and they work together on achieving a goal. We have in food science, for example, in nanotechnology and energy. So when you have these big networks, you can be ensured that you can achieve the sustainable development goals because you have the experts working on them. In addition, of course, they play important role in the education because education is the major issue here, especially in the schools. So when you have good scientists producing good science and better science, which is one of the important aims and challenges also of the decades, this will definitely reflect on also the quality of education. Yeah, so, and of course, the network of scientists, however, we also, I mean, UNESCO promotes multi-stakeholder engagement. So we work with policymakers, with non-scientists, with the society in general. And again, the decade will try to ensure the link, to emphasize this important link between science and society. And yes, this is what I can say, and thank you so much for listening.
So thanks a lot. So it was excellent to hear all of that. So I think maybe we have, so Michelle, so you had a question, and maybe George, so I don't know, anything, because you had to leave as well. So now from this global north. So you see, so there is a lot as well to go on, and thanks a lot for those ideas. So hopefully we'll meet again in June and maybe earlier than that. So thanks a lot, George. So Michelle, then, yes.
Okay, thank you. It's a good opportunity for me to make an intervention because it is very in line with what Amal mentioned about the international decade of sciences for sustainable development. So I want to elaborate a little bit more on how at least in my mind, I see this decade. First, as Amal said, the decade was born from the main outcomes of the International Year of Basic Sciences for Sustainable Development. I want to highlight two main outcomes of this international year, which are a bit contradictory or complementary, you will see. First, basic sciences, curiosity-driven, construct the pool of knowledge which future generations will use for their development. So in some sense, it's clear that they are essential for sustainable development. But although essential, they are not enough. We understood all together during this international year that we need to embark all sciences. What I mean by all sciences, it's basic and applied, natural and social, and even human, and embark all knowledge, including traditional, if we want to go for sustainability. In addition, for sustainability, we should promote new ways to do science. And what we are promoting, instead of having scientists in an ivory tower giving recommendations and people listen or do not listen, we want to promote another way to do science, to have laboratories or hubs or centers where you mix scientists together with the society, which I mean by that people from the society, NGOs, private sector, public sector, decision makers. And this should be happen at all scales, villages, provinces, nations, continents, and globally speaking. So we have the goal of trying to get, at the end of the decade, to have thousands of transdisciplinary, what we call transdisciplinary centers, which means interdisciplinary in the sense of science, but transdisciplinary in the sense of having scientists together with the society stakeholders. Thousands of them interconnected, a little bit in the same way, maybe it is a bit naive, in the same way that thousands of laboratories were interconnected by CERN for the Higgs boson discovery, with what we call the LHC, the World LHC Grid. So we would like to have a World Sustainability Sciences grid of transdisciplinary hubs. So this is the goal. As you know, for the LHC grid, CERN was a center because there is a big infrastructure at CERN, but you could think also of a big central organization for this grid or web of sustainability hubs. You could have a center with an infrastructure devoted to collect all the data, all the software, the best practices, and even think of trying to build a digital twin Earth, which is very ambitious. So adding all the knowledge to try to have an ambitious, powerful modelization, so to see if all things happening at all scales are converging towards sustainability. So the basic idea is that we should, in some sense, create the spirit for sustainability sciences, which presided to the creation of the CERN international organizations at the end of World War II. This was already discussed, Barbara alluded to that in 2015 in Geneva, at the UN Geneva, where everything started there at the UN Geneva headquarters, when we had a meeting on the model of CERN for sustainability sciences. Thank you. So this was my intervention. I wanted to be short because we are short of time.
Yeah, exactly. So this is very important to have taken all those different points, and as well concretely how we could see that it's very ambitious indeed. If we could model everything, this complexity, it would be perfect. But soon we'll have quantum computer, and maybe that's also a solution. So looking at all those different diversity, indeed, actually, next year is the International Year of Quantum. So within this decade, so it's some interesting aspect looking at how we could drive as well this way forward. And I know that in every country, there are different groups as well, thinking as well in terms of how they could contribute. And this aspect, this question we should all ask, like how, at which level, that's one thing, but as well with the multidisciplinarity. So what you respect and what also Amal was explaining, like, for instance, or I would see the A in STEM also with the STEAM becoming with art or with any kind of action as well, that at every level, maybe it's easier for everyone to understand art. We all have a perception, we all have emotion that will be able to be easier as well to explain. And exactly like also what Barbora was saying, like storytelling, we need to build up maybe like a little book that will be easier for the younger generation as well to read. So I think there are plenty of ideas that emanate from that. So indeed, Barbara, your question, and maybe I would like to have you as well answering from from Anna Labrador as well. We had a question related also to what you were describing. So first your question, and maybe we can have as well you answering Anna live.
Yeah, yeah. Thank you very much for all the interventions. Amal, great. Michelle, I am so happy that there are so many great things and opportunities and things to do in a multidisciplinary, transdisciplinary manner. And it's really the time of huge opportunities, and it's so exciting. So I'm really looking forward to this new decade. I would like to mention also, unfortunately, George left, but I will catch up with him anyway afterwards. The idea which he was proposing to create a book of which engineers or scientists has done something amazing for the world. So I have been now for 10 years in this International Particle Physics Outreach Group, IPOC. And I founded the working group which aims to write the stories about the applications of particle physics, but also physics and whatever fundamental research, let's say in general, for society. So we are aiming to do that, and I think that that is the it's great to connect the dots with others who also have a lot of input, and maybe to do something more serious than just on voluntary basis work. Working group. So I'm really looking forward to follow up with the others on this subject. My question to Amal was actually, as you know, I have provoked a little bit with the eligibility criteria for the regional coordinators. And at least in 2015 or a few years ago, it was not really for physicists. So maybe it changed. I don't know. Maybe if you can comment on that, it would be great. Thank you.
Thank you very much. Thank you, Barbara. I mean, eligibility criteria, as I said in my intervention, UNESCO works with everyone, and UNESCO promotes a multi-stakeholder engagement. So the eligibility criteria often extend beyond actually the scientific community. The scientific community works specifically on what is related to science. However, non-scientists such as policymakers, educators, civil society representatives, professionals from different fields, they may be eligible to participate based on their expertise, based on what kind of advices they give, based on the contributions to the relevant goals that we want to achieve. So I cannot say that there is really specific eligibility criteria. It really depends very much on the goal of the goals that we want to achieve in the end. And UNESCO works definitely with everyone. And what Michelle said, that multidisciplinarity is very important. We want to remove the barriers. We want to remove the barriers between the scientists and the non-scientists and the general public. And we want everyone to understand that science is a daily practice, even if you don't realize it. So this is one of the important aims of the decade that we hope to achieve. So I really, it's really, I can't say that there are really specific criteria. We work with everyone. So thank you.
That's great. Thank you. For the question, there was a question indeed about the initiatives targeting early childhood education. So I can just say that for example, when designing with all these stakeholders, the project Youth at STEM for Sustainable Future, we all agreed that it's important to tackle the students already from early age. However, when we decided to do the pilot, it was necessary to start somewhere. And therefore, even like working with industries, etc., it was easier to start first at high school level. But the goal is to go for sure to earlier ages. At least if I can say for myself, I let others to comment on it if you have.
And I think you gave as well one way, so the way as well with your project as well, you handled that. So I think it was really, really good. But I would like really to come, because all of this also, I mean, Physics Matter comes also with the idea, the initiation of Sesame as a project, as a place as well, where everything as well is possible. It became a reality, became from a dream, and somehow this dream as well, can we say that with this decade we'll keep it? We don't know, but this is really a challenging situation now in the Middle East. So how do you foresee that it will happen in this decade, looking at how this strategy could be implemented? What do you think is the potential change of orientation in the Sesame policy as well, scientific policy in any case? How do you see the situation with the Middle East?
Well, let's start from what is Sesame. So Sesame is the synchrotron light for experimental science and application in the Middle East. It is a synchrotron radiation facility. Synchrotron radiation facility is the other way of using accelerators, which provides intense beams. Essentially, it's a sort of collection of laboratories which bring to the next level what you can do in the laboratory in your university, in your research center. And these kind of facilities are very common nowadays in North America, in the Far East, in Europe, but very few of these are available in the rest of the world. So Sesame was born as on the idea of CERN as a intergovernmental initiative of governments and scientists to bring together expertise and bring it to the next level. So in this way, it recollects quite easily with Michael what Michelle said on, because what I am understanding now that I am here for since a few years is the need of building a network of laboratories around Sesame. It's not the fact that Sesame has to stay there as an example of excellence in the region. No, it has to bring together ties with all kinds of laboratories around and work together with those. Otherwise, it will not be effective. These facilities are extremely effective from the point of view of sustainable development goals. If you map them for all synchrotrons, at least 13 out of 17 of these goals are related to what we do in medicine, archaeology, cultural heritage, material science, energy, you name it. Matter matters. So in this case, but really building a place where all laboratories can cooperate is the real mission of synchrotron radiation in this sense, I think. You bring the expertise from your laboratory to the facility, and you bring back expertise to your laboratory from the facility. And while you are there at the facility, you meet other people and you cooperate. So from this point of view, the Sustainable Development Goals can only enforce the mission of a facility like this.
Yeah, that's exactly the point with the capacity as well for the scientific collaboration. And we saw how strong the collaboration is as well. I mean, those light sources, they are everywhere in the world. I just put as well lightsource.org as well as a place where we gathered a lot of those information about the light source. But to see the strong commitment and the strong engagement of all the different community, and in terms of basic science, as you said, so this is there, so the open gate for the future as well, in all the different domains of what will make society certainly better and improved. And then can we, what do you think, looking at, you have the 8 countries that are members, so any kind of difficulty that you encounter over the last 2 years? Or can you give example of the different cooperation that you had that you couldn't have, or what could be possible in the community?
Well, there are a few for the moment international groups collaborating in one single experiment. For the moment, what is important is that everybody still sustains sesame in this moment. This has not faltered so far, and then you must rely on individual sensibilities for how to bring this on, obviously. But the destiny of sesame is not has not changed so far.
This is really good. And what I think is excellent is this, so the collaborative aspect, the workshop that you have engaged, the courses as well. And I think everything on your web page as well is a really important source as well of knowledge for everyone in the world.
Yeah, there is a school in these days at ICTP, which we organized together with the with LAMP and the African Light Source Initiative on synchrotron radiation, which had quite a success. The first year we had 100. We are now at 300 participants, and still growing. I think.
Yeah, that's really important to notice that, and as well with the IUPAP, because then we'll have Michelle speaking with the IUPAP, just to mention this working group 14, where we tried as well to bring accelerator as well at the center of all of that. So from high energy physics, but a lot as well with, I mean, the photon and in this case, in my case, so the proton. So particle accelerator, again, being the center of capacity building.
Well, the neutrons have exactly the same destiny as photons in this respect.
And that's why the outreach, we gather now everything, looking at all the tools that we have been developing for photon or for neutron is the same approach. If you look at the material, so from the other side, and if you look as well for life science, it's the same possibility, even better with the neutron maybe, but it's complementary in any aspect. So indeed, so that's important. And Michelle, so looking at indeed from your point of view and the IUPAP, and then I would like to have you answering the question from Cheryl that she put as well in the question and answer after.
Okay, so this time I will speak as the president of IUPAP. So IUPAP supported Sesame from the very beginning and is also supporting the LAM projects, which is light source for the Americas, for Africa, for Asia, for Middle East, and for the Pacific. The LAM project is based on Sesame, but for other places, and Africa first. The idea is a multi-purpose. These light sources, I think, are multi-purpose, like most of big science. First, they do good science. Second, they connect science to technology and industry. They do a lot of science for the SDGs. Certainly, the light sources are very important for the SDGs. And the CERN also has big science, is important for SDGs. And they do science for peace. Sesame is emblematic for that. So this is exactly what IUPAP is promoting for big science in general. This is the message I wanted to pass. Thank you.
Yeah, very good. So with respect maybe to the question and answer, we saw that there were some, so sorry if we couldn't get everything in a quick and prompt time. So maybe, Michelle, if you don't mind to answer the question from Cheryl, where she was asking, so looking at the weapon industry as well, so rulers, so the different aspect, I mean, to work on equipment. So what do you think on that? So can we hear from Michel Spiro, how do we deal with the weapon industry who graduate to work on equipment that are not promoting peace? So should
yeah, you're right. This is an
Yeah.
important question. In fact, big science, in some sense, people are associating. This is an aspect which is not often mentioned, but in the mind of people, big science and weapons industry are a bit associated. So we have to work in showing that big science is try to disconnect big science from a weapon industry and try to associate big science to peace, to collaboration. Big science is exemplary for collaboration. And this is, I said that for sustainability, this is the type of collaboration that we want. Sustainability is now approached by negotiation. We want sustainability to be approached by collaboration, which is very different from negotiation. And this is a feature of big science, which has to be taken as an example for sustainability. But I agree with that we have to be careful not to connect big science to a weapon industry. And this is a kind of thing that we have to be careful about it.
Maybe just one thing. For this, I completely agree. And this is a big surprise, which always comes once there are, for example, visitors coming to CERN. And we explain that CERN convention was really, there are two things. One of them is never to use anything to army. And the second one is to give everything what we find for free. And so this is a big shock, because this is exactly the DNA of the big science model of collaboration.
I agree.
Yeah, I think I fully agree with
The CERN convention should be an example for all big science to avoid any compromission, any connection with weapons.
Indeed,
It goes without saying. So in Sesame statutes, yeah, exactly the same point.
Exactly. So I think it would be good maybe to even think on a paper for if we think about the ESOF forum, or maybe also with respect to the big science, to try to find ways as well to gather all this sort of thinking. So you were speaking, Barbara, as well on the next one. I think is in Trieste. So for the big science. And then looking at the Euroscience Open Forum as well, I think to find ways to have ways to follow up as well on those potential, and also because we have the Alan, also the APS leadership meeting, so in just a few days from now, so we could certainly as well raise all of that thinking in terms of concrete ways through. And through all the different research infrastructure, we have different grants that already exist. So to try to list up, to put that database, I mean, this is what Michelle was suggesting. So I think it's really a way to start as well. Everyone should maybe send us or find a way as well to combine this. I mean, same way, of course, Physics Matter, we could collect part of that because we have now this committee for the communication and outreach, so we could think in terms of a way to disseminate further the information. So that could be ambitious, but then we can maybe think in terms of how to redistribute, how to pattern. And we were discussing also, of course, with Barbara to have also her from her project perspective a way through. And I see that we have one of our student ambassadors as well, Cyrus, who has a question, and certainly he would be really like the perfect person as well, thinking about data, how to manage all of that to help us with that. So again, ideas that we can promote and move forward. So Alan, so you had also a hand raised.
There we go. Can you hear me now?
Yes, that works.
First of all, I want to reflect on this idea that next year is the International Year of Quantum. It's been there's really good evidence from economists and other parts of society that in fact 50% of global domestic product is due to quantum mechanics. You've probably heard this quote before, but it basically refers to the applied physics that was done at Bell Labs and in many labs across the world, developing information technologies and so on. So that's something that needs to be emphasized, I think, when it comes time to demonstrating the impact on humanity. I believe it was Barbara who mentioned that this is an important factor for recruiting girls to physics. And I think we're still missing something here that I can't put my finger on, because if you look across the different cultures of the world, the participation of females in physics varies drastically. Compare, for example, Japan, which is 9% female representation in physics, of course, to Portugal, which is above 50%, or I think, perhaps Andrea can comment, Jordan is even higher in terms of female participation. So somehow when we have missed a term in the Hamiltonian that, if we discover that term, we might be able to break through on this issue. Barbara, you're shaking you're agreeing with me. What do you think?
Yeah, I fully agree. There are countries where it's completely opposite, especially the countries like Jordan and also the others in the Middle East. There are like even more than 50% of girls who are in sciences. And I think this is really worth to discover and to investigate how it's organized there and what are the, how to get the lessons learned and do there is a lot to do.
And it depends a lot on the condition, the boundary condition, I would say.
Yes.
Indeed, you remember, Alan, we had in Iran, for instance, we were also presented by Reza, who was mentioning that it's 64% of it's not the PhD, but of the physical society in Iran that were women as well. So there was such an active role, engaging much more so for the women and the girls, so then for the boy. But then as well, we had at the same time by the local, I think it was anonymous, but we had also an explanation that it could be because also of the fact that the girl would have maybe more difficulty to start working right away, whereas for the man it is. So you see, it's really cultural. It's really depending on the country, depending on the boundary condition. But indeed, that's something that was an investigation. So another way as well for a student somewhere on the planet to study that. So I think maybe through or motivated as well by UNESCO, because I'm sure you have a lot of data that could support all of that as well. So Amal, yeah.
Thank you, Christine. Thank you, Alan, for this note. It's actually something interesting, and you can notice it if you are from the region. So I come from the region. I'm a physicist, so I can somehow I lived this experience. It is indeed in the undergraduate level, students who study science, and also in the postgraduate level, you can easily notice a lot of women actually in the field of chemistry and physics. And the mathematics. However, the situation changes completely when you come to the leadership positions. So they can start, of course, studying basic sciences, maybe in the postgraduate also. Again, for a reason, very important reason you mentioned, Christine, that it's easy for men maybe to find jobs, but not for women, and so they go to study because this is something they can do. However, this stops at some point when it comes to positions and leadership positions. The situation becomes completely different. So this is not sustainable. It is there is still a problem, a big problem actually, and it varies a lot. It varies a lot. So in Africa, for example, there are still a lot of problem with women. So we receive quite often requests from professors who are trying to find the solutions to help their female students who unfortunately they are really smart, they want to continue, but they can't for many reasons, for many cultural reasons, for example. So there are a lot of issues we still need to address, we still need to work on. And again, I stress on the fact that in the leadership positions in the field of science, there are still a lot of problems, not only in the developing world, but also in the developed world. So I think we all have to work together to address this issue. We have a lot of programs, of course, at UNESCO to support women in science and education. We have the L'Oreal program, more than 25 years now at UNESCO, working in many different regions of the world. And we have many other programs. We have grant programs to support scientists, and we try to achieve the gender parity somehow. So we try, but this is not enough. We need the help of the governments and the NGOs, the society, to make this issue, to find solutions for this problem. Thank you. Thank you for raising this very important issue. Thank you.
And this point, Alan, so it's good to be raised as well by a man, but it really brings a lot of attention as well. And we see from our audience, so we have a lot of point example indeed in terms of how and what it meant as well for them. So I think it's everything will be safe. So sorry if we cannot come to also your question or your comment, but thanks a lot for engaging and to participate. It feels like indeed a family. We are quite often like feeling that what can we do, but when we can hear and participate and have as well already some solution that you have proposed at UNESCO, and then how we can really try to encourage and communicate. So what we'll do, we'll keep anyway all the potential email available. We'll see how we can get this feasible. All the different presentation will be there as well. I just would like to have one last question before as well. So Michelle, also we need actually to close very soon, but from Sirius, so Cheryl, we completely hear as well what you said. So I just mentioned that she was mentioning about how we could raise the parliamentary. So definitively the policymaker have to be educated with all those different aspects. And that's part of how we could maybe address also that audience with some different movies or maybe interviews or things that could be proactive there. For Sirius, so you were mentioning indeed the role of data and transfer, knowledge transfer. What does this data and knowledge transfer plays in the grid of sustainability that was mentioned by Michelle? So Michelle, do you have just like few words to finish on that? The data and the knowledge transfer, this is key words also for me. So I like that, Sirius. Thank you for the question.
Yeah, yes, so the key goal of this decade, as I said, is to interconnect transdisciplinary laboratories. When I say transdisciplinary, this means scientists together with the society, working on given issues, on given problems, to collect all the data, to check them, to monitor the data, to monitor the advancement, to share the software, to try to elaborate the best, to get out the best practices, and to use all the know-how to put it in the modelization of the